Hello and welcome to Science Never Stops. I'm your host Joseph Vick with the U.S. Space and Rocket Center, and today's topic is states of matter. Now, there are 4 states of matter. 4, and let's start at the lowest. And we're going to be working with the molecule of water. So when we're talking about water in a specific type of molecule, we're going to call it a phase. Water has 3 phases, but we'll go along with those phases as well as along with the states of matter. So matter is, first, anything that has mass and takes up space. So that's anything from the smallest of small atom, electron, quark, anything subatomic, to the biggest of big. A galaxy, a sun, a planet, the biggest of big to the smallest of small. Anything that takes up space and has mass matters. Now, the first state of matter is a solid. Also, these states of matter can flow from one another with the movement of energy, the transfer of energy from another into another. The first is solid. So I have in this beaker, and this is a solid. Notice the 2 different colored pieces of cereal would represent the water molecules, hydrogen and oxygen. So this is solid. Notice it is a fixed volume and shape. It is staying inside. Notice, but there's a little bit of jitter to it because at the molecular level in a solid there is some vibration. Because just like you see the pieces here, they're very close to one another, squeezed together in that fixed volume and that fixed shape. It's close, it's compact, and those little bits of vibration moving among one another is what happens at the molecular level in a solid. Now, the solid state, or the solid phase of water, is at 0 degrees Celsius. We call that ice, or in Fahrenheit it's 32 degrees Fahrenheit. So that's when we had solid ice, whether it's outside on the top of a lake, or we pull it out of our freezer and we put it in a glass of iced tea. That is the solid state of water. Now if I add energy, but it's not brain energy, it's energy in the form of heat. So if I add heat energy to this, the solid state of water, which is ice, will do what? It will melt into the second state, liquid form. So I have it blue here, so it's over-exaggerated blue. The real chemical color of water is blue. If you put it in a white bathtub or a sink, you'll see a nice blue lining around the sink. That's another experiment you can do. But we have here water. Notice as I move it, it flows. Water takes the shape of its container and flows about. So it's taking the shape of this cylinder beaker that it's in. If I were to pour it into a star shape or a sphere or a square shape, it would also take the shape of that container. So water flows, and water is sort of the middle range of the states. It is between the temperature range of 0 degrees Celsius, so you can have liquid water at that in between once ice is melted at 0 degrees, and 0 degrees Celsius, and you can have it as hot as 100 degrees Celsius or 212 degrees Fahrenheit before it reaches that steam point. So water flows. Water flows, our second state of matter and the second phase of water. Now the last is the highest energy of water. So I have in my hands a balloon. That happens to be the gaseous form or the vaporous form of water. Just like water, gas takes the shape of its container, but it can expand greater in a room. All the air in a room is gas. All the air that I'm about to add to this balloon, it's taking the shape of the container of the balloon. Now, in the science of aerodynamics, water and air are somewhat equal. Air is considered a liquid in the science of aerodynamics. And to put that in a simple explanation, boats sail through water, airplanes sail through the air. Has very similar properties, but they both take the shape of their containers. But gas is a higher energy level, spreading out everywhere around us. Now, there is a fourth state of matter. Now, in my home kitchen and yours, we do not have the energy capability of forming plasma on the stovetop, which that's a good thing because plasma is very dangerous. That's the point where all of these little molecule pieces, I'll take some from the solid, these molecule pieces start to reach a point where they break apart, where you reach a level where these things start to break apart because there's so much energy, so much heat that you form this plasma. Now, the best example of plasma is the sun. The sun is an active furnace that is moving and shaping and spitting out all kinds of plasma as it's a nuclear radiator of all of that energy. So think of the closest thing, the safest thing that we can sort of feel when we go outside is the sun. Now, you can't be around plasma because it's extremely hot and it will very much hurt you. But let's look at these three phases of water in our own home kitchen. You can do this experiment on your stovetop. I have my handy stovetop here, and I have a beaker filled with solid form of water, which is ice that I pulled from the freezer. You can feel it is cold. It's cold and it's touching my hands. And on the outside, you can already see, because it's warmer in the room than it is inside this container, you have some condensation, or the liquid form of water, forming on the outside. You can do this experiment home too on your stove eye. You can get a container, a stovetop safe container, fill it with ice. I also have a thermometer. This thermometer happens to be a meat thermometer, so it's not the best thermometer to use, but it's what I had on hand. So we're going to be able to see the temperature go up. Set that in there. So it won't tell me that it's 32 degrees or 0 degrees Celsius, because it doesn't start until it's at the 60 mark. But it's at the 60 mark, meaning that I know it's cold enough. And in order to change from one phase of water to the next, you need to add energy. And the energy that we're going to do that with is heat energy from the stovetop. So I'm going to move this over to high heat. As you observe, you'll begin to feel the radiant heat coming from your stovetop, whether it be electric like this stove eye is, or gas. You'll have the feeling of heat energy radiating outward in the form of infrared heat radiation. That is also emerging up and through. I'm starting to see now some movement of the ice from the solid form, and starting to see a formation of liquid at the base. Let me move it a little bit closer here. There at the base, you're starting to see some liquid formation at the very bottom, closest to the energy source, the heat source. And if you look a little bit closer, you'll see there at the bottom, and then running from the bottom to the top, this emergence of vapor. The vapor is the gaseous stage of ice, of water. So you're going through these various phases of water based on the amount of heat or the amount of energy you're putting into it. Check my temperature. Oh, it's moved up. Oh, that moved up quickly. So what it did, there was vapor that went from the base, it evaporated, went all the way up, and the temperature gauge lists it as close to 200, which is great because the gaseous form, or the gaseous phase of water, solid to liquid to gas, is 210 degrees Fahrenheit. So continue to sit back and watch, and also time it. If you have a watch, if you have the watch or the clock on the wall or your cell phone, see how long it takes for your container of solid ice to then move from solid ice to liquid water, and then how long it takes for that liquid water to move from liquid water to the gaseous form of vapor. One thing I do want you to know is to be very careful. We can handle ice with our bare hands, but the heat is dangerous. So we don't want to touch the stove eye. We don't want to be really close to it, especially when it reaches the gaseous level of phase. So we want to be very careful in the kitchen, make sure our parents are there to help us out and controlling the stove eye for us. Also, from observation, you'll be able to see the beginnings of bubble formation. Bubble formation within the water means that at the very level where the container that you have your ice in is touching the heat source, you'll have a bubble form. And that is a bubble that is holding gas that has collected from that evaporated liquid, bubbling up and then escaping out through the top of your container. We'll continue to let that boil, and we'll come back when it's in a full rolling boil. Now we've reached the phase where you have all the ice that has liquefied into water based on the amount of heat energy that we have added, and you have a rolling bowl now with the water, and you have water vapor or steam or gas emerging from the top of the beaker. Now we have reached this level where there is high energy. See all those bubbles and gas violently moving about? When you reach this level of, or this phase of matter with water, you have gas that will go out, expand, and fill the container, which the container would be the room that you're in. To demonstrate that, I have here some blue food coloring. And based on this high energy and the gas movement, I wanted to show you that this could be like something diffusing throughout a room. Diffuse in the way of, let's say you open a smelly bottle of perfume. It's really close to the perfume bottle to start. It's smelly right there, but eventually if you leave it out and open, all those molecules will go out and fill the room, and you'll smell it all over the house or the room. So with this high energy state, I'm going to add a drop or two of the food coloring to see just how fast it's going to diffuse throughout with this phase. That was very quick. So with a gas, it expands out and fills a room because the molecules are moving really quick, and it zooms out and fills up the room quickly because of that high energy state. So this is the showcase for our solid, liquid, and gas phases of water. And then there's the last phase of matter that we can't do in our home kitchen, which is plasma, which we can see and experience with the sun. But think of matter all around you. Look about your home, look outside in nature. What states of matter can you find throughout nature, throughout where you live in your home? Write those down in your journal and notice that these matter pieces are ever changing. So always remember to keep your eye out, your brain open, and science never stops.